In the previous video, we talked about how to check a function or how to check the convexity or concavity of a function by using derivative. But here we are going to talk about the checking of a function whether it is concave or convex by using Hessian determinant. Now, before going to the Hessian determinant or how to form a Hessian determinant, let me simplify some of the terms before. Now, here y is given as function of x1 and x2, that is equal to 2x1 square plus 5x2 square. So at first we will find out the first order derivative of y with respect to x1, that will be equal to 4x1, and the second order derivative of y with respect to x1, then that will be equal to 4. And then we have to find out the second order derivative of y with respect to x2, then that will be equal to 0, because there is no term of x2 in the first order derivative of y with respect to x1, because the first order derivative of y with respect to x1 was equal to 4x1, so there is no term of x2 in this 4x1 term, so the second order derivative of y with respect to x2 will be equal to 0. Similarly, if we do the differentiation of y with respect to x2, that will be equal to 10x2, and if we find out the second order derivative of the y with respect to x2, then that will be equal to 10. And similarly, if we find out the second order derivative of y with respect to x1, then that will be equal to 0. Now we have basically found out the derivatives of y with respect to x1, and then we have found out the derivatives, that term that we have obtained from the derivative of y with respect to x1, we have differentiated it twice. At first we have differentiated it with respect to x1 again, then we have differentiated it with respect to x2. Similarly, in the second case, we have differentiated y with respect to x2, then we have differentiated that result by x2 again and by x1. Now let us form the Hessian determinants. So the first Hessian determinant, that is h1, will be equal to d square y by dx1 square. That means the second order derivative of y with respect to x1, that is equal to 4. You can go back in the previous portion of the video and can find it. Second Hessian determinant, that is equal to h2, will contain 4 elements or 4 terms. What are the 4 terms? That is d square y by dx1 square, d square y dx2 square, d square y dx1 square, and d square y dx2 square. So if we put out all the values of the terms, then that will be equal to 4 0 0 10. The determinant is obtained in the form of 4 0 0 10. By solving the determinant, we are getting the value of 40. Now we can see easily from this that the Hessian determinant, that are the h1 and h2, both are positive. So now if h1 and h2 both are positive, then we can say that the function is convex, as shown here also, that the function is convex. So that means if all the Hessian determinants are positive of a function, then the function is convex. Now we will try to generalize it. So suppose the function of x and y is equal to x into y or xy. What is f1 here? f1 is the partial derivative of function of xy with respect to x. I am saying it again, f1 is the partial derivative of the function with respect to x. So basically f1 is nothing but the partial derivative of x into y with respect to x, that will be equal to y. What is f2 here? f2 is the partial derivative of the function with respect to y. That means f2 is the partial derivative of xy with respect to y, that will be equal to x. Now what is f11 here? f11 is nothing but the partial derivative of f dash xy with respect to x. That means at first we have done the partial derivative of the function with respect to x, and we are going to do the partial derivative of the same result with respect to x again. So what will be equal to that? So basically we are doing the partial derivative of f1 with respect to x again, and it is becoming f11, and what will be the result of it? The result of it is 0, because we are actually doing the partial derivative of y, because the value of f1 is y. So we are doing the partial derivative of y with respect to x, that will be equal to 0. Similarly, what is f12? F12 is the partial derivative of f1 with respect to y, that will be equal to 1. What is f22? F22 is the partial derivative of f2 with respect to y, so that will be equal to 0 again. And what is f21? F21 is the partial derivative of f2 with respect to x, that will be equal to 1. Now, how can we form the Hessian determinant in the generalized way? H1 will be equal to f11. I mean, the value that we have obtained in the form of f11 will be put in the H1 determinant. What will be equal to H2? H2 will be equal to a matrix, or H2 will be equal to a determinant which will be equal to f11, f12, f21 and f22. By solving this h1 and h2 determinant, we can find out that a function is convex or concave. Now, if h1, h2, h3 all the determinants are positive, then the function is convex. But suppose h1 is negative and h2 is positive and h3 is negative again, that means if we are having the odd number of determinant, then that is negative, and if we are having the even number of determinant, then that is positive. If this type of sequence goes on, then we have to say that the function is concave. That means I am trying to say that if h1 is negative and h2 is positive and h3 is negative again and h4 is positive again, h5 is negative again, so if this type of sequence goes on, then the function is concave. Now let us check with the function that whether it is convex or not. The function is given as f of x, or function of x, equals to 7x plus 2. If we find out f1, now you can remember what is f1. F1 is the partial derivative of the function with respect to x. So what will be equal to f1? F1 will be equal to 7. That means the entire function, that is 7x plus 2, if we try to derivative it or differentiate it with respect to x, then that will be equal to 7. So h1, the determinant of h1 is equal to f1 is equal to 7. Here we can't find h2 because it is made up of only one variable. If it is made up of two variables, then we can find up to h2. If it is made up of three variables, we can find out up to h3. Now, as only h1 can be found and h1 is positive, so we can say that the function or f of x is convex. That means from here we can easily say that any linear function that has the form of ax plus b is convex where a greater than 0. Here the function 7x plus 2 basically has the form of ax plus b where a is equal to 7 and b is equal to 2. So when we are getting that a is greater than 0, that means a is 7 here, which is obviously greater than 0. We are having a convex function because of a linear function which is having a form of ax plus b where a is greater than 0. Now we will try to find out whether this function is concave or not. This function is given as minus 7x plus 2. We have found out the f1 again, that is equal to minus 7. So obviously the Hessian determinant or h1 is minus 7, that is negative. So if h1 is negative, the function of x is concave. Now we can say from here that any linear function that is in the form of ax plus b is concave where a is less than 0 or a is negative. A is minus 7 here, which is negative, that's why the function is concave. So here another function is given towards us, that is the function of x is equal to 7x square plus 3x plus 2. Now at first we have to find out f1. What is the value of f1? At first we have to tell what is f1. F1 is basically the partial derivative of the function with respect to x. Now what is the value? The value is 14x plus 3. Now what is here we haven't obtained any value of f1. We need a number or any simplified value. Then for getting it, we have to find out f11. Now what is f11? F11 is basically the partial derivative of f1 with respect to x. What is the value of the partial derivative of f1 with respect to x, that is equal to 14. Now h1 is basically 14, that is positive, so the function of x is convex. Now from this we can say that any quadratic function that is in the form of ax square plus bx plus c is convex if a is greater than 0. Here the quadratic function 7x square plus 3x plus 2 is convex because 7, that is basically a, is greater than 0 or positive. That's why we are having a convex function. Similarly, it will hold for any quadratic equation that is having ax square plus bx plus c form and a is less than 0 or a is negative, then we will have a concave function. That is, the proof of that is also given here. Now let us check the convexity or concavity of a function with respect to two variables. If there are two variables given in a function, then how can we check the convexity of the function? Now here function of xy is equal to x square plus y square. Now at first we have to find out f1. What is f1? f1 is basically the partial derivative of x square plus y square with respect to x. Then the value will become 2x. Now then we have to find out f11. What is f11? f11 is basically the partial derivative of f1 with respect to x, that is basically the partial derivative of 2x with respect to x, that will become 2. Similarly we have to find out f12. What is f12? f12 is the partial derivative of f1 with respect to y, and that is basically the partial derivative of 2x with respect to y, and that will become 0 because there is no y in the term of 2x. Now then we have to find out f2. f2 is basically the partial derivative of x square plus y square with respect to y, that will be equal to 2y. Then we have to find out f21. What is f21? f21 is basically the partial derivative of 2y with respect to x, that will be 0, and we have to find out f22. f22 is basically the partial derivative of 2y with respect to y, that is equal to 2. Now in the previous models or in the previous examples we have just taken the h1. If h1 was positive we have declared the function as convex, and if h1 was negative we have declared the function as concave. But the previous functions were basically made up of only one variable. But if we consider this case, the function is basically made up of two variables. So here h1 is not enough. We have to find out h2 as well, because h2 can be obtained where we have two variables. In case of only one variable in the equation, then we have to find out only h1. If it is positive, then we can say the function is convex, and if it is negative we can say the function is concave. But here the number of variables are 2, so we have to find out h1 as well as h2. What is the value of h1? That is the determinant of f11, that is equal to 2. What is h2? h2 is the determinant of f11, f12, f21, f22. We have determined all the value of f11, f12, f21 and f22 in the earlier portion of the video. We have to just put it into the determinant and then solving the determinant. By solving the determinant we have found out the value of h2 is equal to 4. Now h2 is positive and h1 is also positive, and we have told in the earlier portions of the video that if both h1 and h2 are positive, then the function is basically convex. So the function of x and y is convex because h1 and h2 are positive.